Do you know what is hybridization? Do you know what is sigma bond and a pi bond and the difference between them? In this section, you will learn these concepts before we move on to the study of organic chemistry. So let's start with a sigma bond. A sigma bond is formed when two s orbitals will overlap, for example, the hydrogen molecule. Or an s orbital can overlap with a p orbital, like in the case of HF. Or two p orbitals overlapping on the same axis will give you a sigma bond. A pi bond, on the other hand, will occur when there is sideways overlapping of the p orbitals. This will give you a pi bond. What is hybridization of atomic orbitals? That is, how the ordinary orbitals, the s, the p, the d, and the f, interact with each other to create new hybrid ones. Electrons moving in atomic orbitals can be considered to be waves, that is, electromagnetic waves. Waves tend to interact with each other. If an s orbital meets with a p orbital, having different wave shape, they will interact with each other and create two orbitals of different shapes and energy. These are called hybrid orbitals, and the process by which this occurs is referred as hybridization. Let us consider methane as an example. Carbon has 4 valence electrons with an electronic configuration of 1s2, 2s2, and 2p2. In such a state, there are only 2 unpaired electrons and there is no possibility for formation of 4 bonds. First, what will happen is that one electron from the 2s will move to the 2p, that is in the excited state. You have 4 unpaired electrons, and carbon is ready to form 4 covalent bonds. The s orbital will hybridize with the 3p orbitals to give you 4 different sp3 hybrid orbitals. These hybrid orbitals will arrange in a tetrahedral structure and form sigma bond with s orbital of hydrogen, conferring the tetrahedral shape of methane. Methane has a tetrahedral shape with bond angle of 109.5 because the 4 different sp3 hybrid orbitals will stay as far as possible away from each other. Ethene. The hybridization is different. Carbon has 4 electrons, so 1 electron from the 2s will move to the 2p and will form the excited state. Then the 2s electron will hybridize with only 2 of the 2p, forming 3 sp2 hybrid orbitals and 1 unaffected p. The 3 hybrid orbital will be in a trigonal planar configuration with the unaffected p being perpendicular. Each orbital will contain 1 unpaired electron. A first sigma bond will be formed with another carbon, and then 4 other sigma bonds will be formed with s orbital of hydrogen. So there are a total of 5 sigma bonds, and the 2 unaffected p orbitals being close to each other and being perpendicular will merge sideways to produce a pi bond this time. So in ethene, in the double bond, you have the first one being a sigma bond and the other one being a pi bond. This double bond will prevent rotation around the double bond so that ethene is trigonal planar and is a rigid molecule. So to summarize, please keep in mind, 1 s orbital merged with 3 p orbitals will give you sp3 hybrid orbitals. You can have 4 of them. 1s merged with only 2p will give you 3 sp2 hybrid orbitals and 1 unaffected p. And there is a third possibility. If 1s merged with only 1p, you will have 2 sp hybrid orbitals and 2 unaffected p orbitals.